Have you been clicking your way through the Azure portal to create resources? Let me show you a better way. Welcome to this video on GitHub and DevOps. My name is Kevin Fiesel, and I'm the proprietor of Catalyxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. Today's video is a little bit of a departure from what we've been doing so far. We are still going to do a bit of work in GitHub, and we're going to use GitHub Actions, but the end goal is to build out and maintain some resources in Azure. Let's learn a bit more about the topic in a more academic environment. There we go. Welcome to the classroom. Today's topic is infrastructure as code. The idea is fairly simple and starts from this concept that our applications are code. We have a set of tools and techniques for dealing with the code we use to build those apps. We store the code in source control. We manage it using tools like GitHub Actions. And typically, we make sure that there is a convenient mechanism to move code between environments to increase the likelihood of each environment being consistent. Meanwhile, for our infrastructure, much of what we think of as infrastructure is still software. Operating systems, drivers, firewall applications, services like Apache or SQL Server. All of this is software. And this becomes even more apparent when we talk about containers, where almost the entire process is managing software. So why shouldn't we use the same tools and techniques for our infrastructure that we do for our own applications? Granted, you won't have the source code to SQL Server, but you can run a PowerShell script using a configuration file to set up your SQL Server the way you want it. So why not save that PowerShell script and that configuration file in your source control? And that way, the next time you create a SQL Server instance, it will look the same as those other instances you have painstakingly worked on. Frankly, it'll probably look more like the ideal than the ones you've painstakingly worked on, because as humans, we tend to miss steps when performing repetitive activities. If you look at even a dozen handcrafted instances in a company, you'll almost assuredly spot some differences, whether due to minor differences in the initial setup process or changes that have happened over time due to performance emergencies or feature requests. And when you're talking about infrastructure in the cloud, scripting is the way to get resources out. Specifically, when talking about Azure, there is a service called the Azure Resource Manager, or ARM. It accepts JSON files in a particular format, and it uses these ARM templates to create or modify resources in Azure to match what you want, assuming you have sent a valid request. Now, wait a second here, you might be yelling at the screen. I only use the Azure portal. I don't do any of these ARM template shenanigans. Well, hypothetical viewer, if you're using Azure, you absolutely are using ARM templates. That's because even the Azure portal builds ARM templates and submits them to the ARM service. No matter whether you're using the Azure portal, the AZ CLI, Azure PowerShell commandlets, uploading ARM templates into the template runner in the portal, or if you're using a service like Terraform to do all this stuff for you, at the end of the day, the Azure Resource Manager service receives a request from you in the form of an ARM template and attempts to satisfy that request to the best of its ability. Given this, it is a natural next step to say, well, what if I just kept these ARM templates and stored them in source control? That way, if I need to rebuild a service, or if I want to have the same service in multiple environments, I could easily do so without needing to remember the exact set of steps I followed in the portal to set this thing up. That's all well and good, but it turns out that ARM templates aren't the nicest things to write from scratch. I know this because I've done it before. Would not recommend. Instead, Microsoft has an entirely separate language for infrastructure as code called Bicep. Bicep is a domain-specific language, or DSL. Domain-specific languages are programming languages whose creators designed them for very specific use cases. For example, SQL is the most popular DSL in the world, at least according to me. SQL is fantastic at data access and manipulation, but you wouldn't want to build entire applications using SQL. By contrast, languages like C#, F#, Java, Python, Rust, and Go, these are general purpose languages. You can use these to solve most programming problems, but they may not be the most clever way of solving any particular problem. Bicep is a DSL specifically for Azure infrastructure as code. Its code is fairly human readable and transpiles into ARM templates. I'm not going to really give a primer on Bicep itself, though if you do want me to dig into the language some more in a future series, drop a comment below and I'll add it to my ever-growing queue. Instead, we're going to make our way into a demo where I'll show off a little bit of Bicep, and then we'll see how we can use GitHub Actions to deploy changes to Azure services via Bicep scripts. Let's make our way to the demo and get going. This demo covers Exercise 3, Task 2 of the Training on Implementing DevOps Practices. In the training, we want people to build out a Bicep template that deploys a specific set of resources into Azure, including an app service plan, a web app, application insights, and a container registry, all in a resource group. We are going to do this for 3 separate environments: dev, test, and prod. Along the way, we'll need to create a secure link between GitHub and Azure Entra ID, so we'll use OpenID Connect to create a federated credential and bridge that gap. We'll save a few things in GitHub Actions repository level secrets and make use of those in a GitHub Actions workflow. I normally say there's a lot to do, so let's get started, but today I'm going to say there's a whole lot to do. So let's get started. In Visual Studio Code, there is a folder called Infrastructure as Code. Inside of that is main.bicep, a Bicep script that has all that we need. As a quick note, if you're following along with the training, your Bicep script won't have all of this fanciness, as there's a comment in there to use GitHub Copilot to help build out the necessary resources. I'm not focusing on Copilot for this series, though I probably will have some videos on it in the future. Regardless, I've got the answers, and that's what we're looking at. We have a parameter called environment, and that's the environment of our web app. We'll use dev, test, and prod as the applicable environments. We're also creating a parameter called location, which is the region that hosts our resource group, like East US or West Europe. After that, we have several variables running from lines 7 through 15, built around a function called unique string. This function is a simple hash function that creates a 13-character string and helps us avoid naming conflicts in Azure. We'll use this function, based on the name of the resource group, to provide us names for the web app, the app service plan, log analytics workspace, app insight service, and container registry. We have a few other variables as well that we'll need to include. After that, lines 18 through 30 cover the first resource we want to create, a log analytics workspace. We base the name on our variable and set the location to be our resource group's region. There are a few properties we need for this resource, including a particular SKU, keeping 90 days worth of log data, and setting a daily quota of no more than 1 gig of data ingested. Don't worry, we won't get anywhere near that cap in this training. The reason we're creating a log analytics workspace is that we'll need one in order to stand up application insights. That's what we create on lines 32 through 40. We can see on line 38 that there is a reference to our log analytics workspace's ID. Lines 42 to 51 have us create a container registry with a standard SKU. Container registries are inexpensive ways of storing custom Docker containers in Azure. Then, lines 53 through 63 build out an app service plan on Linux. We're using Linux-based Docker containers because we're not monsters here. Most of us, at least. All of this is necessary preamble for the finale. Lines 65 through 101 cover building our Azure app service. We can see references to the app service plan, container registry, and application insights in various settings throughout here. There's a lot on here, but taking it a line at a time, we can understand exactly what's going on. And that's an advantage of Bicep over ARM templates. I wouldn't exactly call Bicep a greatly human-readable language, but it is a far sight better than trying to read ARM templates directly. Great, we have a Bicep script. Well, now what? The next thing we're going to do is navigate to the Azure portal and create a resource group. In the search menu, I'll type in resource group and select the resource groups service. From there, I'll select create to add a new resource group. Let's call it video demo, and I'll make sure that the region is East US. After navigating to the review tab, I'll create this resource group. The next thing we're going to do is configure OpenID Connect, or OIDC. There's a lot to do here, so let's strap in. Here we are in the Windows terminal. We are going to spend a fair amount of time using the AZ CLI tool. You can, of course, do all of this work in the Azure portal as well, but we're going to stick to the command line for this. I'm going to need two variables early on, my Azure subscription ID and the resource group name I used. I already set the subscription ID beforehand in a variable called $subscription ID, so that's why you only get to see the resource group name here. The next thing we're going to do is register a new Azure Entra ID application registration. I'll call this DevOps integration. As I run this command, I'll get back a block of JSON text. From here, there are two particular things that I need. The first of these is the app ID, which we'll eventually use as our Azure Client ID secret. I'll copy the GUID here and store it as $app ID. The other thing that I need is the value in the ID field. I'll copy this into a PowerShell variable called $object ID, and we'll use this in a later command. Now that I have everything I need from the app registration, let's move on to the next step, and that is to create a service principal based on my app ID. There is another command within the Azure Entra ID CLI module, and I'll pass in the app ID as our required ID parameter. This is again going to spit back some output. From here, I want to grab the app owner organization ID field and save it in PowerShell as the variable $tenant ID. We are going to use this ID as our Azure Tenant ID secret. The other thing I need to grab from here is the Service Principal Object ID, which is our ID field here. Let's save that as $assignee object ID. With a service principal in place, the next step is to grant that principal rights on my resource group. To do so, I'll use the AZ role assignment command and create a new role assignment. We'll grant the service principal contributor on the video demo resource group and all of its resources, which admittedly is nothing right now, but soon it'll be something. Note that we need the subscription ID, the resource group name, and the assignee object ID. Finally, we'll specify that the assignee is a service principal. The last thing that I need is a credentials file, which contains parameters specifying relevant input parameters in JSON format. Let's quickly go to Visual Studio Code and take a look at this parameter file. We can see in here the name of the federated credential we're going to create. Then, we can see that the issuer comes from GitHub. The subject explains what this credential will have access to on the GitHub side. Repo means that we scope this to a repository, and then we can specify the account or organization name / the repository name. The description is for us and explains why we have this federated credential in the first place. Finally, my audiences ties back to Azure Entra ID and its token exchange. Let's create the federated credential now. It should only take a moment for this to work, and once we do have it, that's all I'll need to do from the command line. Now that I have everything in place, let's perform the next step inside my GitHub repository. I'll go to the settings page and then drill into secrets and variables and choose actions. This allows me to create repository secrets, and I'm going to create 4 in total. The first will be called Azure Client ID, and it will contain the app ID variable I created earlier. Note that I'm just copying in the GUID itself without any quotation marks or other characters. The second secret will be called Azure Tenant ID, and it will contain the tenant ID variable from before. The third secret is the resource group name, which we'll store in Azure RG. The final one is called Azure Subscription ID, and will contain the subscription ID. We've already added that one because, to be honest, I didn't want to show it on screen. The next step is to create a GitHub Actions workflow for deploying the resources in our Bicep script. Let's switch to VS Code and pick up from there. I have in the .github/workflows folder a script called deploy.yaml. The script itself is pretty short, but it does have a lot of information, so let's take a look at it. On lines 1 through 10, we can see the trigger criteria. In this case, we have one trigger. It is workflow dispatch, or a manual triggering. Inside of here, we have one environment variable called appinv. This will display a drop-down list, allowing us to choose one of dev, test, or prod as our environment to deploy to. Line 12 gives us the name of this workflow, Azure Bicep Advanced. Then, on lines 13 and 14, we kick off our one job, build and deploy. This job runs on an Ubuntu-based VM and requires a few permissions. The one that's the most important is ID token of write on line 19. If you don't include this, you may have problems authenticating with Azure using your federated credential, so be sure to include it. Line 20 is where we start filling in the 3 steps we'll use for this job. The first step is to check out the repository on our GitHub Runner VM. Then, lines 25 through 30 cover authenticating with Azure. We're going to send the client ID, tenant ID, and subscription ID. Because we're using a federated credential, we also need to enable Azure PowerShell sessions. We'll need all 4 of these parameters to complete the login process. Finally, lines 33 through 39 actually run the ARM template. By the way, that name and the GitHub action of Azure/ARM deploy may sound a little confusing as we're sending in a Bicep script. But this GitHub action is smart enough that it can take a Bicep script and submit it as well, letting the ARM service compile it down to an ARM template. We'll send in the subscription ID and resource group, as well as the location of this Bicep script. Finally, we set the environment equal to the value from that dropdown. Great, I have that in place. Well, now what? Now it's time to kick off some workflows. I'll navigate to the Actions tab in the GitHub repository. In here, I have a new workflow on the left-hand side, Azure Bicep Advanced. Selecting it, I have a workflow dispatch trigger, so I can select the Run Workflow dropdown on the right-hand side. In here, I have 2 options. First, I can select the branch. I'll leave that as the default of main. The second dropdown is new to us, and it asks me to choose the target environment. We can see in the list that I have dev, test, and prod options. I'll start with dev and select Run Workflow. This will kick off the GitHub Actions workflow, send dev as the environment, and execute the Bicep script to deploy resources. One nice thing about this approach is, if my Bicep script changes, I could always rerun the script and deploy out those changes. That's an advantage to writing Bicep scripts over dealing solely with ARM templates. We can specify something closer to a desired state and run against that. Now this will take a bit of time, so I'm not going to have us sit here. Instead, let's speed up time a bit. Great, the job has completed and we've got our resources out in Azure. Now let's switch over to Azure and jump into the Video Demo Resource Group. Inside of this group, we can see that the resources the Bicep script created are available to us. Off screen, I'll also run this for the test and prod scenarios so that we have everything we need for later videos. That was a pretty busy demo. We did quite a lot here, but the end result is we are now set up to manage our cloud infrastructure the same way that we might manage application code. In the next video, we're going to expand a bit on this idea and get into the dynamic duo of continuous integration and continuous deployment. We'll have links and show notes in the description below. And until we see each other in the next video, take care.